We looked earlier at systems of equations, and we graphed two lines and looked for where they crossed. You can actually do something very similar with inequalities, and we're going to see here now what that looks like. So which ordered pairs solve both inequalities? That's what a system is. It's more than one inequality at a time. Well, for our example here, I've got these two. So we're going to do a quick refresher on how you graph these, and then we'll talk about where we can find the solutions to this system. Here we go. Let's start with, and I realize I have the advantage of being able to use different colors, so I'm going to take advantage of that. We're going to have this first one be our red one. All right, y is greater than or equal to negative 2x minus 3. Start off by treating it like a line. So pretend just for a moment that it's y equals negative 2x minus 3. This is going to get us our boundary line. Starting point at the back, that y-intercept of negative 3. The slope of negative 2, I need you to remember that's really negative 2 over 1. So to get to your next point, move down 2 and to the right 1. So down 2 and to the right 1. And then our line goes through there. Now, not only can you go down 2 and right 1, but to keep that same slope, couldn't you also go up 2 and left 1, right? So I'm just going to put a few more points on here to make it easier to sketch in my overall line. Now let's think. I've got the little equal bar underneath. So which does that mean? Does that mean dashed line or solid line? If I want to include the boundary, and that's what the equals means, then I want that line to be solid. So here now I'm going to try my best. Ooh, that's not. Try it again. Go like this. All right. Drawing in my line, trying my best to make it straight. And there we go. That's my boundary line. Now, the question is, where does the shading go? Greater than, because the y is on the left, means I want to shade above the line. We can also, again, do a test point. I recommend using 0, 0 as a test point. So why don't we do that over here real quick? The shading is going to be above, which means when I do 0, 0, I should get something that is true. So here is our test check. Put a 0 in for the y. Put a 0 in for the x. We're trying to see if we get something true or something false. Well, this is going to be 0 greater than or equal to 0 minus 3. 0 greater than or equal to negative 3. 0 is greater than negative 3. So sure enough, that's true. So I'm going to be shading above my red line. So any ordered pair that is in this shaded red area, including the boundary line, solves this top inequality. Let's do another now with the blue. So the same thing. We're going to treat it just for a moment like an equation. Start at a height of 1. And the slope is 3/4. So go up 3, right 4. So from the starting point, up 3, right 4. You could alternatively go down 3 and left 4. Notice those are all on that same line. This is just a less than, meaning this boundary line should be dashed. So a dashed boundary line. Boundaries not included. And it's a less than, which means we're going to shade below. Now, just for a test check purpose, why don't we run through another test check? Now, I'm going to use 0, 0 again because that tends to be the easiest ordered pair to use. I want to just note here, this was a true test check. I'm going to come back down here. So 3/4 times 0, that's just 0. 0 plus 1 is just 1. Is 0 less than 1? Yes, it is. That's true. So that means this test checkpoint of 0, 0 is in the shaded region, which is below the line. See how that works out? So my shading for the blue is going to go down in here. So here's what we see. We've kind of got now 4 regions on this graph. we've got this part here with no shading. These are the ordered pairs that don't solve either of the inequalities. We've got a portion here that is only red. Those would be the ordered pairs that solve only the top inequality. We've got a section down here that's blue only. Those would be the ordered pairs that solve only the blue inequality. But then we have this section where they overlap. That's where we find the ordered pairs that solve both of them at the same time. So I'm going to give this region a little highlight. All these ordered pairs make both inequalities true. We actually saw that with our test check, right? We chose the ordered pair, the origin, 0, 0, and it made the red one true. It made the blue one true. It solves the system because it makes both inequalities true at the same time. Let's summarize this here in our toolkit page. So I'll let you fill in those blanks. Simultaneously just means at the same time. Now over here, I'm going to use this as an example. I'd like you to include whatever example you think is most helpful. So to graph, I'm going to, again, use colors because I have the ability to do so. So y less than negative x, I'm going to do in red. So first, I want to put some marks here on my axes. Then 5 up and down. So y less than negative x. Well, negative x is really like negative 1x plus 0. So that means start at 0 and go down 1, right 1. It's a less than, so this will be a dashed line. And it's a less than, so I'm going to shade below. Now, if you're doing a test check, don't use 0, 0 this time because 0, 0 is on the boundary. When you're doing your test check, you need to pick a point that isn't on your boundary line. Next, let's do 1/2 x plus 2. So, sorry, that clearly says a minus. So start at minus 2 on the axis. For your next point from there, go up 1 and right 2. So up 1, right 2. Up 1, right 2. So it's going to look, it's a solid line because of that equal. It's going to look something like this. And the shading will be above. And I'm just going to make a note here then. My solutions to the system, those occur here in the overlapping part where the blue and the red are crossing over one another. Those are the solutions to the system because they solve all of the inequalities simultaneously. To wrap this up, I just want to look at a couple more examples. So I would encourage you, you can get a marker board. We got a new batch of marker boards, and on the back, they have coordinate grids already. So if you want to grab one of those and sketch on there, that's not a bad idea. Or you can use your paper as well. So try this one. Do a quick pause and then unpause when you're ready to check. Just to make it as clear as possible, I'm going to again use different colors. So for this first one, I'll use my red. So negative x plus 2 is start at a height of 2, slope of negative 1, so down 1, right 1. That's a equal to underneath, so a solid line. Really, I'm trying my best here to draw a straight line. It's not terrible. And a less than equal, you can do a test check. If you put in 0, 0, you get a true statement. That'll be a less than, so shading below the line. And you'll notice that when I do it's called hatching. When you draw these little lines in, this indicates that it's shaded. So if you're using like a pencil, you can just shade it in with your pencil if you want. That's fine. You don't have to draw these hatch lines, but you certainly can. Okay, next, y is less than 3x. This one I'm going to do in blue. So remember, this is kind of like 3x plus 0. So your starting point is right at the origin. And from there, 3 is like 3 over 1. So you go up 3, right 1. Or you can go down 3, left 1. just as long as when you're finished, you should have that positive slope. This is just a less than, so a dashed line this time. And the shading should be below the line. So do it my hatching. And there we go. Where are the solutions to the system? Right here in the overlapping section. So you can see there are some ordered pairs that don't solve either inequality. There are some ordered pairs that solve only the red inequality. There are some ordered pairs that solve only the blue inequality. But down here, that's where we solve them both. And just so you know, when you look at the answer key for the practice sheet, it won't show all the shading. It will only shade in the overlapping part. So when you check your answer key, it's going to show only the overlapping part, just so you're aware. Okay, I do want you to know that there is no problem with these inequalities, but they can be a little tougher to understand because they don't follow the typical format. But nothing's really different. We still have two inequalities. We're going to do one in red. We're going to do one in blue. I need you to remember back to the first semester when we were graphing our lines. If you had y equals a number, that meant your y coordinate is always the same. The y value is always -1, which means that you can go at a height of -1 all the way you want to the right and left, but you can't ever go up or down. This is going to be a straight horizontal line. So a straight horizontal, it's got an equal to underneath, so it's going to be a solid line. Just like that. So there you go. That's y equals -1. Now let's do the shading. Greater than or equal to -1. Let's do a test check. I'm going to use 0, 0. If I put a 0 in for the y, do my checks over here. So my test checks over here. If I put a 0 in for the y, I would put a 0 in for an x also, but there is no x. So we don't have to. We just need to ask, is this true or not? Is 0 greater than or equal to -1? Yes, it is. So that means the origin is a solution. Therefore, all the shading here should be above the line. So all of those ordered pairs up there have y values that are greater than or equal to -1. We're including the boundary in this. Next up, for x less than or equal to 3. If the x coordinate is always 3, that means I can't move to the right or the left. If I can't move to the right or the left, the only direction I can go is up and down. So at 3, 1, 2, 3, on the x-axis, I can go up forever, I can go down forever. But I can't go side to side because that would change the x-coordinate. Now let's do again a test check. I want to see whether I should be shading to the left side or to the right side. I'm going to use 0, 0 as my checkpoint. Put a 0 in for the x. I would put a 0 in for the y if there was a y, but there isn't. So is this true? Is 0 less than 3? Yes, it is. So this point is a solution. Therefore, all the points over here are solutions. So I'm not sure why those lines are going so long. Bring a couple of you back, whatever. Here's then what we have. The same thing that we've seen in the others. It's just that this time it's a little more rectangular. We've got a section down here where there are points that are not solutions to either. Here are some solutions only to the first inequality. Down here are some solutions only to the second, but here in the overlap, that is where you find the solutions to the system.